across the nation. It is definitely cold all around. That cold air mass affected quite a bit of us. Even down in Miami, they've cooled down a little bit this morning as that air has completely made its way off towards the east and down towards the southeast. It's 0 in Nashville right now. They've got quite a bit of snow. A lot of these temperatures up north, though, like yesterday when we looked at them, they're about in those negatives. Here today, though, they're in those positives, and we're looking still towards pretty cold temperatures, but a few degrees warmer in a lot of places today. Heavier storm coming from Lubbock off towards some of our northern counties this morning as well. So we take a closer look at that storm. Lots of lightning, maybe some gusty winds and some heavy rainfall heading towards Benjamin and Haskell this morning, maybe even dipping down towards Snyder. So we take a closer look towards Abilene as well. Lots of thunder showers out there right now, some heavy rainfall. So the roads are very wet. So make sure you're being very careful as you're heading out the door, maybe taking some extra time to get to your destination this morning. Clear up a little bit towards 5 o'clock, but then we get another round of those showers coming towards later this evening, overnight tonight into tomorrow morning, really coming through our area tomorrow afternoon through the evening, which is likely to bring us a lot of heavy rainfall. Biggest concerns there being large hail in some of these storms, also flooding. So we'll keep an eye on that. Some roadways are already very wet and flooded this morning. So as you're heading towards work or school or anywhere this morning, please be careful on the roadways. Do not drive through anything flooded. Turn around. Do not drown because your car can quickly get swept away in just a few inches of water. So we have those southerly winds today that are going to help warm us up with quite a bit of sunshine. So you can see here they're starting to pick up quite a bit towards 5 o'clock. That's when we get those really strong gusts later on this afternoon. We get that first front Thursday afternoon, then we get a second cold burst of that cold air Friday, which is really going to cool us down. Here this morning as you're heading off to school or work, bundle up, grab all the things you can grab to keep yourself warm. It's going to be about 20 degrees, mostly clear, but still a little bit breezy out there. And as you're heading home, 51, sunny, windy for most of this afternoon. So even though it's going to be in those 50s and sunny, it's going to definitely be cooler. Good Wednesday morning, everybody. Taking a look out in South Abilene, those conditions are very wet this morning, and on the other hand, there's a lot of fog going on as well off towards the east in Callahan County here. We're looking towards lots of foggy conditions here this morning. That's going to continue for most of us with patchy fog throughout the morning as well as light misty conditions for most of today. As we get into overnight Tuesday, though, those storms begin to continue to head our way, still staying less than severe, which is good for us, but we need those rain chances to Tuesday morning, so still some scattered showers. And as you can see here, this color that's kind of tracking behind those storms, that's accumulated estimated rainfall, so kind of looking at what we hopefully will get. As you can see, some of that blue color is around 2 inches, and some of our areas are likely to get that off towards the west there. No stranger to tornadoes, but do you know how they're formed? We have to have a thunderstorm first, but also your surface level winds and stronger upper level winds. Now these winds are typically moving at a different speed and direction, and that's called is wind shear. So when these cross, it creates a rotating column of air on the ground level, and then you have updrafts and the thunderstorm, which is wind moving up into the thunderstorm, that then creates this column of air to move vertically in the air and then producing a wall cloud in that thunderstorm. That wall cloud then produces a rotating column of air that pushes downwards to the ground. If it doesn't reach the ground, it is just considered a funnel cloud. But if it does reach the ground, that's the point when it's considered a tornado. What we're looking at here is hail damage from a storm that came through this past summer, bringing quite large sizes of hails and damaging windows and roofs, as you can see there, something that the big country knows all too well. And here's a common occurrence with these hailstorms is that they occur March through June, so spring through summer, and those stronger storms typically form large amounts of hail, causing about $1 billion in damage each year. So here in Big Country in Abilene, we definitely contribute to that damage each year. So now that we've talked about what those storms are like, here's how they're formed. We talked about updrafts with tornadoes causing that rotating column of air, but updrafts also bring frozen water droplets swept up into the air above a freezing level, and each time that additional layer is added, it's because that water droplet is moving up and down above that freezing level. So it's going up and freezing and then dropping down and melting. And as you can see in this graphic here, each time it gets an additional layer of that ice, causing it to be much larger. Now eventually these updrafts will not be strong enough to hold that hail there, so that force of the updraft is exceeded by the hailstone weight, dropping it down to the ground. Now I once was asked why in a storm sometimes there are certain areas that get very small hail and other areas that get very large hail, and that's because once again that updraft can be stronger in certain parts of that storm. So one updraft could only be strong enough to hold pea-sized hail, while another updraft could be strong enough to hold grapefruit, baseball, or softball size hail. Which, speaking of, let's go over those sizes of hail compared to what our normal objects would be. Looking at these sizes here, they get severe very quickly. So looking at pea size being the smallest, about 1/4 of an inch, marble, penny, and then nickel, once we stop there, everything above that becomes severe levels of hail. Getting up to 1/4 right here is about an inch, a ping pong ball, a golf ball, and then all the way up to grapefruit size. You know when you look up in the sky and you see those white puffy things? Well, they have quite a few more names than just clouds. There's also a few interesting facts about clouds that we can go over here. Clouds are not actually weightless and can become very heavy. Gray clouds do not always mean rain, and I mean this saying that when that cloud becomes very dense, the sun can no longer shine through the cloud, creating a shadow effect there. A lot of the times rain does come from those gray clouds, but more often than not, they're just blocking that sunlight from coming through. Now there's also 3 main groups of clouds there: cirrus, stratus, and cumulus clouds. So let's go over what each of these clouds are and kind of where they are in that atmosphere. So we go all the way from the troposphere all the way to the stratosphere, which is up towards where the planes fly. And you have cirrus clouds sitting very high in the sky, very light and wispy clouds, but then you also have these subgroups of those clouds. So you have cirrocumulus, which are a little bit more puffy, but they kind of lay in long streaks across the sky. You also have cirrostratus, which kind of lay in a light, very thin blanket, kind of like when you see overcast skies. But then you also have these altostratus clouds, which are a little bit more in that mid layer, a little bit more puffy, but they also lay across that sky there. And then you have altocumulus clouds here on that next layer, but still kind of in that mid layer, kind of a little bit more puffy, also bringing out kind of a bit of that, covering a bit of that area there. Now that other subgroup is that stratocumulus, but also stratus by itself just means that it's covering across that sky. They're kind of laying in a blanket type way. You also have the stratocumulus, like I just mentioned, so they're stratus, so laying across the sky, but a little bit more puffy, which comes from the straight cumulus clouds, which are typically associated with that rain, with those rainstorms there. So just cumulus are the typical puffy clouds you see on a day-to-day basis, 9 times out of 10, pretty spread out across the sky. But then you have the nimbostratus clouds. These are much bigger, kind of once again associated with those storm clouds. And then you have the cumulonimbus clouds. These are really associated with those really strong, severe storms. These big clouds that kind of billow up, and they go all the way from the bottom layer here all the way up towards the stratosphere there. As you can see, quite a bit of increase in that height there. Also with these nimbostratus clouds kind of reaching up to the mid layer, because when you have those storms, those clouds are able to reach up into those layers and kind of produce those stronger storms there. So now when you go outside, challenge yourself, and if you look up in the air and the sky, you can maybe tell yourself, what kind of cloud is that? And you can kind of use this as a guide there and figure out what it is just besides a cloud.